Welcome to MathLink Academy, where we're going to connect the dots. I am Mr. C, and I will be covering this particular lesson, which we're going to talk about triangles. So we're going to talk about the beginning of triangles and how that look. So let's get started. Let's talk about types of triangles. I'm going to start off with the word polygon. A polygon is a closed plane figure formed by three or more segments. And what I want to talk about with polygons, the word poly is a Greek word which means many, and gon means side. So we're looking at many sides. In this particular unit, we're going to talk about a triangle, which is a three-sided polygon. So a triangle is a polygon, but it's with three sides. The sum of the angle of a triangle is 180 degrees. That's very important. I want you to remember that or memorize that the sum of the triangle is 180 degrees. And so I'm going to circle that so we make sure that's important. So all three angles, when you add them together, is 180. An equilateral triangle has three equal sides. It also has three equal angles. So if I'm going to draw a picture of an equilateral triangle, I'm going to try here. Here's one that we want to see if all the sides are equal. And how I normally refer to the sides being equal. So if this side has one dash, this one has another, this one has one. So all those dashes, or one dash, means that all those three sides are equal. Also with the equilateral triangle, the angles are equal. So here's an angle. That means this angle is equal and this angle is equal. Now remember, if all three angles of a triangle, no matter what type of triangle it is, equals 180, and all three angles are the same in the equilateral triangle, we're just going to divide 180 divided by 3, and that will give us 60. And so each angle in an equilateral triangle is 60 degrees. So let's continue to talk about types of triangles. One type is called isosceles triangle. Now, isosceles triangle has two equal sides. The equal sides are called legs, and the third side is called the base. The base angle of isosceles triangle are equal. The base angle are opposite legs. So the base angles are opposite the leg. So let me just show you an example of what we're talking about by isosceles triangle. So when we talk about isosceles triangle, we want to show you how it can look. So here's a leg, and here's a leg, and they're supposed to be equal. So let's make sure they're equal. And then here's a base. So for this particular, here's my dash there, one dash, and then we'll make this two dash because that has a different length. So the one dash all have the same length, and the double dash has a different length. And that's an example of isosceles triangle. Now, don't always think they're going to be standing up like that. They may be angled differently, but you got to recognize it has two equal sides. And then the third one is the base. So this is our base, and these are our legs right here, leg and leg. Another thing that's important to remember, on the base, these angles are equal to each other. So notice I have two dashes there. So on the base angles are equal to each other. And that's what it means that the base angles are opposite the legs. So the base angles are equal to each other. Now, another type of triangle we're going to also talk about is a scalene triangle. It has three unequal sides. It has three unequal angles. So an example of a scalene triangle can look something like this. So here's an angle, or here's a side, excuse me. Here's another side, and here's another side. And so this side has this length, this side has another length, and then this side has another length. So notice I have three different marks, and it's telling me that these three sides have different length, and also the angles, all three of the angles are different. So make sure you understand a scalene triangle has three unequal sides, while an isosceles triangle has two equal sides. And what we discussed earlier is that an equilateral triangle has three equal sides with three equal angles. Again, we're going to talk about types of triangles that I want you to make sure you memorize or be familiar with. And so this is an important type of triangle that we want to talk about either later on in some of our future videos, or you may have saw them in the past videos. And it's called a right triangle. A right triangle has a 90-degree angle. And the symbol for a right triangle is a small square placed at the vertex of the angle. The opposite side, or the side opposite to the right angle, is called the hypotenuse. And the two other sides are called legs. So for example, we'll look at this. Here is an example of a right triangle. That's a leg, there's a leg, and we're gonna put this here. Now, once I put this square, that's telling me that that angle is 90 degrees. That tells me it's 90 degrees. So normally if I don't see that square, it may not be 90, it may be 91 or 89, but that tells me it's 90 degrees. And in this case, our hypotenuse is opposite to the 90-degree angle, which should be right located there. And then these two are called legs. Here's a leg here, and here's a leg. They don't have to be equal. Now the hypotenuse is the longest side. So if you want to do your calculations correctly as you look at some other videos, make sure when you get your final answer, if you know the two legs, your hypotenuse should be the longest side as far as measurements. Another type of triangle is called an acute triangle. It has three acute angles. Again, acute angles are angles that are less than 90 degrees. So try to draw one yourself. Draw an acute triangle where it has three angles that are less than 90 degrees. Another type of triangle is called an obtuse triangle. It has one obtuse angle and two acute angles. And so obtuse angle, we're talking about is greater than, in our case, greater than 90 and less than 180. So draw a triangle that has an obtuse angle and then two acute. Try that on your own. You can pause the video and see if you can do that yourself. So let's look at an example when we talk about types of angles or triangles. And let's keep in mind all the definitions I gave to you earlier, and then also use some of the skills or some of the math subject matters that we talked about in using this example. Now, if you need to refer back to how to find degrees, minutes, and second, feel free to look at the previous videos that we have in the MathLink website to know how to do this. So I want to show you the basic way of how to find the answer using our particular slide. So for this example, in the figure below, we have angle A, B, C, are holes that are center angles. There's center line angles. And angle A equals, it says 48 degrees, 35 minutes, and 52 seconds. And then angle C, it has the angle or the degree of 87 degrees, 57 or 55 minutes, 27 seconds. Now, what we want to do is find angle B. So we got to refer back to what we've learned in the past. And here is angle B. We want to find angle B right here, what I'm really highlighting. And in this case, what we want to do, we want to realize some of the theorems and what we know. We know that three angles, when you add them up in a triangle, equals 180 degrees. So we know if we add angle A, B, and C should equal 180 degrees. So What we just need to do now is just add angle A and angle C. Just add those together. And we'll use what we have done in the past of knowing how to add our degrees, minutes, and second. And remember, the key number is 60 when you convert and move over, and then subtract 180 from that answer, and that will give us angle B. So quickly, let's look at how the process looked. Again, I'm just going to talk about the process. So in this case, we're going to use the theorem that the sum of the angle of a triangle is 180 degrees again. So angle B is determined by 180 degrees minus the adding of the other two angles. In this case, we're going to let this slide show us the adding of the angles and then subtract 180 degrees. So in our case, when we set it up, we end up with 43 degrees, 28 minutes, and 41 seconds. Now, knowing that all three angles are less than 90, this is an example of an acute angle, or acute triangle. And so this is our answer for this particular problem. Now let's look at some more properties of some special triangles, isosceles triangle and also an equilateral triangle. An isosceles triangle, an altitude to the base bisector divides into two equal parts, the base and the vertex angle. Now I'm going to explain that in a minute, and I'm also going to say about an equilateral triangle, an altitude to any side, and instead of any side, bisects the side and the vertex angle. So let's start with, in this case, the isosceles triangle. So an isosceles triangle can look like this. It has two legs that are equal and the base that is on the bottom. Now what this is saying, this property is telling us if the altitudes from the top to the base, a line from the top to the base, and it hits the base at a right degree angle. Notice I have that square that says that's 90 degrees. Now notice we have two triangles. We have one here and one here. Now I'm not focusing on the two triangles, but what I want to focus really on is, in this case, we're looking at what this definition is saying, or this property is saying. This property is saying that the altitude, which is in red, what it does, it makes it's a bisector to the base, so that these two, it gives us two equal sides here on the bottom. So that base is broken down into two, I'll say, parts or sides, and they both are equal. So an altitude to the base that bisects, it gives us two equal parts. And again, this is coming from the vertex. This is a vertex. Now for equilateral triangle, it's a little different, because an equilateral triangle, all three sides and angles are equal. So let's say that's an equilateral triangle. And what it's saying is you can pick any vertex. Let's pick this vertex, and you can go perpendicular. You hit that base perpendicular, or another side perpendicular, and it makes these two, where it divides it, equal. It doesn't matter what vertex you use for an equilateral triangle, and go down to the next or the opposite leg or the opposite side, is going to give you those two equal sides back and forth. So this equals from there to there. So that's basically what this property is saying. So let's put this property into action or practice that will give you an example to look at. So this example, it says side DE. So look at where side DE is. side DE and side EF. So here's DE, here's EF of the triangle are equal. So if they're equal, then that's telling us that we have an isosceles triangle. Okay, not an equilateral, but isosceles triangle where two sides are equal. And we have a piece, EG, where E, and find where EG, here's EG. I'm going to give you a different color so you can see it. Here's EG, is to fasten to the frame of the additional support. So we want to determine angle 1, angle 2, and the distance DG. And the distance DG, the tongue twister right there, is at this distance here. So let me clear this, and so we can see, and maybe you can see how we're going to attack this problem. Now I'm going to say something going back to this bisector. The bisector is EG. It also gives us two equal angles, not just two equal sides here, but two equal angles where it bisects. That's what we call it, the bisector. So let's look at this, guys. So looking at this triangle, since this is forming a right degree and the length is 12 feet 4 inches, we can say in this case, this will go with the property and it divides this in half. So this side will be what? 6 feet 2 inches. And this side also will be 6 feet 2 inches. Then also, as I said earlier, if the whole angle up here, it tells us is 116 degrees, this is telling us, since it's a bisector, it evenly bisects, and it's an isosceles triangle, that we just take half of 116 degrees, which our case, we get 58. So this is 58 degrees, and this is 58 degrees. Angle 1 and angle 2. But let me clear this and show you the work that is done earlier. Again, since it's a bisector, the angles at the vertex where it starts at will be divided by 2, and also the base will be divided by 2. Now in this case, it would be 6 feet 2 inches, not 3. That's not correct. It'd be 6 feet 2 inches as an answer. So hopefully this helped. If you have any questions when we're talking about types of triangles, please feel free to review this video or look at some of our supplementary material that we have. Again, let MathLink bring it together. Thank you again for watching this video.